Is that right? No scientific notation? Okay, how about this guy? The mass of the block. What?
91.875.
Okay. How big is this block? How wide is it? Remember in graphics, this is always the width? 175 millimeters. What's its height?
300.
Millimeters. And what's its depth? What's the length of this cylinder? 75? And what's the, do they give you the radius or the diameter? What's the diameter?
75. So we don't know how far that steel penetrates the brass, do we?
We're going to assume that it was connected right there. It's not going inside. Otherwise, they would have to tell us that. Okay, so how many bodies do we have here? 2. Where's my y-axis? The y-axis is running through right here, right? So, the moment of inertia of the block around the y-axis, and the moment of inertia about the cylinder through the y-axis. Let's do IYC, IYB. So go on those the tables, and for a block, let's look at what the equations are. Okay, so for a block, I see a 12, an m, a b squared, an h squared, and all that stuff. So, could you tell what the difference is? Look at where the x-axis is on the picture here, on that page. It's 52. Notice which 2 dimensions give you the value for the moment of inertia. It's b and h. What's the relationship between b and h and the x-axis? They're on the plane that's perpendicular to the x-axis, right? Look at the z-axis. What are the 2 dimensions that are perpendicular to the z-axis? L and H. Are you guys all looking at page 52?
No.
Okay, look at the rectangular prism. See where the x-axis shoots out from the rectangular prism? Does everybody see where the x-axis shoots
I
out?
have that on 52. I have beam.
Page, is it 52 or something else?
I think you just can't see
It's
the page.
stapled up the corner.
Table 10-4?
Yeah.
Table 10-4.
All right, so that's what I got.
So for the rectangular prism, if you look at where the x-axis is, notice the plane that's perpendicular to the x-axis is the BH plane. Does everybody agree? Notice the moment of inertia about the x-axis takes into account B and H and does not take into account its length. For the z-axis, the plane that's perpendicular to the z-axis has a length L and an H, a dimension L and H. So sure enough, it makes sense because look, when an axis is shooting out and you're trying to find the moment of inertia, you're looking at the area around it. You're not looking at the area along that line. Okay? So in this particular case, we know that it's the moment of inertia about the block is going to be 1/12 times m of the block times what? So it's squared plus squared. So look at where the x-axis is. And look at our dimensions. We have a 200, we have a 175, and we have a 300. Which dimensions describe the plane that's perpendicular to the y-axis? The 200 and the 300. That is the moment of inertia about the y-axis going through this block. Why did I not have to do the parallel axis theorem?
It's going to the center.
Because the y-axis that they're asking us to find the moment of inertia about is through the center of the block. Okay, how about this guy, the cylinder? Let's take a look. There's 2 cylinders here. One is called a slender rod, and one is called a circular cylinder. Look at the values that are used to calculate the moment of inertia. And think about then, are we dealing with a slender rod or a circular cylinder? The circular cylinder. Why? Because there's a radius defined. In the slender rod, it's so slender that the radius really doesn't even come into play in creating a moment of inertia about that axis. But look at this, we're looking at 175, 200, 300, and a 75. That's still substantial. Maybe if it was 10 millimeters, we would say it's slender and it's not going to take into account. But as long as they give you a radius or a diameter, you're going to have to take into account. So we're looking at a circular cylinder. So now, which equation do we want? The one that says a half or the one that says a 12th? So take a look at the axes. The half is of the x-axis that's going through the center along the length. The z and the y-axis are perpendicular to the cylinder. Now take a look at our problem. We're trying to find it about the y-axis that's going through the center. So which equation is it? Is it the half or the 1/12? A half. So 1/2 mass, 1/2 the mass of the cylinder times, is it the radius? 75 over 2 squared? Squared.
Oh, I see, because they rotate their axes, axes.
That's right. So you can't look at their x, y, and z. You can't use their x, y, and z axis. Think about when we went back all the way to the beginning of the semester. I said to you that you could put your axis wherever the hell you want. Because I'm going to look at your free body diagram and see where you put your axes, and then all your numbers are going to be based on that. And that's true always. We could always rotate our axis. We could put it wherever we want. So the textbook has the x-axis coming through the center. Yours, in this problem, has the y-axis. So the importance is not whether you're using x, y, or z, but what's important is the orientation of that axis in terms of the body. So the y-axis here corresponds to the x we're seeing